This is part 3 of our video lecture. It has to be through PowerPoint because unfortunately there isn't a way to show this except for through pictures, and I think that's the best way of helping you. We're going to go through classifications of matter. So you'll see at this chart, matter is broken down into two main substances, pure substances and mixtures. And the pure substances are in purple and the mixtures are all in pink. And we're going to go through each piece and what they mean. So pure substance is a kind of matter that cannot be separated into any other substances by physical means, such as heating, cooling, filtering, dyeing, sorting, or dissolving. Again, that is a pure substance cannot be separated into different kinds of matter by physical means. Okay, so that is the definition of that, and then we'll go down to elements. And if you follow the purple down, you'll see that there are elements on the left side and compounds on the right. We're going to start with elements, and an element is a substance that cannot be separated into a simpler substance by chemical means. So an element is the smallest form that you can go. You can't get any smaller than an element. Element is the true pure substances. Elements are the most fundamental pure substance from which all matter is made up of. So again, element is a substance that cannot be separated into simpler substances by chemical means. And you'll see that there's metals, metalloids, and nonmetals for the elements. And then compounds are a substance containing more than one element in which the atoms of different elements are chemically bonded together. So remember, these pure substances, you can't break them apart by physical means. However, and elements can't be broken down at all. They're the smallest piece. But compounds can be broken up chemically, not physically, but chemically. So like H2O, which falls under compounds, can be broken up with hydrolysis, and we did that last year. So again, compounds are substances containing more than one element in which atoms of different elements are chemically bonded together. And then you'll have organic and inorganic. And we don't typically at this level of chemistry go into those organic and inorganic. Organic has to deal with carbon, anything related to carbon, and inorganic is everything else. So then if you follow over to the pink is the mixtures, and you have heterogeneous and homogeneous mixtures. And mixtures are matter that contains more than one substance. So mixtures are matter that contains more than one substance. And then you have, for mixtures, it breaks down into homogeneous and heterogeneous mixtures. And if you remember from last year, I told you, if you can remember, like homosexual, homogeneous, they're the same. Heterogeneous with heterosexual means different. Homo means same, hetero means different. So homogeneous mixtures are mixtures that is uniform throughout, in which any sample has the same composition as any other sample. It's the same throughout. Where heterogeneous mixture is a mixture that is not uniform, in which different samples may have different composites. So a mixture that contains more than one type of matter and is the same throughout is homogeneous. A mixture that contains more than one type of matter and is not the same throughout is heterogeneous. So, and I'll give you examples of all of this stuff. And then you have suspensions, colloids, and solutions. So you'll see that solutions are under homogeneous mixture, and a solution is, hang on, I'm freeze framing. So a solution is a homogeneous mixture that consists of a solvent and at least one solute. Right? And then we'll get into those terminologies a little later, but if you want to look it up, you can look it up. And then suspensions suspensions have the largest of all dispersed particles. In suspensions, you can separate them. So there's a clear separation between both of them. And then colloids are dispersive particles are larger than those in solutions and may be visible on close inspection with a microscope. So solutions and colloids look very similar. The difference is colloids have bigger particles that you can kind of see, and I'm going to give you the difference as we go through the examples. And then suspensions they break apart. So elements, again, can't be broken down. They're already in their smallest form. The periodic table, as you see here, the diagonal, if you remember correctly, is the green, which is boron, silicon, germanium, arsenic, antimony, tellurium, and what's that one? AT. I forgot what AT is. I can't remember off the top of my head what AT is. It'll probably come back to me later. So from that green line over to the left side is all metals. The green is all metalloids, and then from the green to the right is all nonmetals. So these are all metals or all elements, and you'll see up in the corner gold, silver, copper. They're all in their natural forms. So these are examples of elements. Example of compounds is shown on this slide. You have like H2, O2. They're two or more elements combined. So like H2 is two hydrogens put together. O2 is two oxygens put together. N2 is two nitrogens put together. Water is H2O, two hydrogens and an oxygen. NO is one nitrogen, one oxygen. So it's two or more elements put together gives you that compound. And again, these are chemically separated. Elements can't be separated, but compounds can be chemically separated. Then you have the heterogeneous mixtures, and I'm sorry, food is the best thing to do this with. Heterogeneous is different throughout. You can pick them apart. So most of you this M&M thing is probably driving you crazy because you like to pick the M&Ms and sort them by color. Nuts are a mixture of nuts, as well as a mixture of fruit in the hamburger as well. You can pick those parts and separate them. So that's heterogeneous. And you can do that by physical means. This is where compounds were by chemical separation. This is by physical separation. You can separate it by their physical properties, and the compounds you have to separate by their chemical properties. This is your homogeneous mixture. Again, they're same throughout. Their composition is the same throughout, such as chocolate milk or tomato juice or these lovely cookies, whatever the cookies are. Now here, remember, we're going down the line, and we're going down, this would be examples in the heterogeneous. Suspensions are in the heterogeneous, and as you can see, they clearly separate. So you see the density column on the left where you have honey, corn syrup, dish soap, water, vegetable oil. They are separated. Same with the other side. You've got a dressing, trying to think what it is. It's a type of dressing and is clearly separated. You probably see this in your fridge all the time. If you have like an oily based dressing, you pick it up, you see the oil on top and all the great stuff on the bottom. And then colloids, this is where I said colloids and solutions look similar. Colloids, the Tyndall effect can be used to distinguish between the solution of colloids. Someone in their project will have the Tyndall effect. So you'll see one that's a solution where it says not a colloid, that is a solution, and then the colloid. The best way is that flashlight. That's why I stuck it in there. The flashlight shines through. You can't see the flashlight through the solution. It just goes right through. But in a colloid, it reflects that flashlight. So you'll see the light. And then, of course, in the suspension, you see everything. And that ends this topic of classification of matter. I hope it helps, and I think that's it for matter, but I'll look, maybe there's one more, but this is the longest one so far, and hopefully this is explained. If there are any questions, please ask me.